Hello, Professor. Today I'll be presenting the Memento design pattern. I'll explain what the pattern is, how it works, the classes involved in the pattern, and then I'll demonstrate how I implemented it in Python using a simple text editor application. The Memento pattern is a behavioral design pattern used to save and restore an object's state. Instead of recreating an object from scratch, the pattern allows us to return to a previously saved state. Common examples include video game save systems and the undo feature found in text editors, where users can return to an earlier version of their work. The memento pattern consists of three main components: the originator, the memento, and the caretaker. The originator is the object whose state we need to save and restore. The memento stores a snapshot of its state, and finally the caretaker manages the saved snapshots and provides access to them when we need them. In my implementation that we will see later, the originator is the text editor class, the memento is the memento class, and the caretaker is the history manager class. Now that I've explained the pattern, I'll show how I implemented it into my application and how each class maps to the memento pattern structure. So this is my code right here. I broke it up into three sections as I talked about earlier. We have Memento, Text Editor, History Manager, and of course main. So the Memento class is responsible for storing the saved text. The Text Editor class contains current content and provides methods to save and restore its state. The History Manager class stores multiple Memento objects and manages to undo the functionality. And during execution, I'm going to save several different versions of different texts and then undo operations to restore earlier versions of the content. You see, these are my messages that I'm going to be giving it, and then we're going to be printing them one by one, undoing it, so it's going to be in reverse, and you'll see why I did that. I made a little message for you. Hello, Professor. How are you doing today? That's the current state. After the first undo, I say that's fantastic to hear, assuming you're doing well. After the second undo, I say I hope you're doing I hope the rest of your day will go well as well too. So of course that's assuming you're having a good day. I hope you're having a good day. And now with the rest of the presentation. This diagram shows how my implementation maps to the memento pattern. The text editor class acts as the originator and stores the current text content. When the save method is called, it creates a memento object containing a snapshot of the current text. The history manager acts as the caretaker and stores memento objects in a history list. When the user requests an undo operation, the history manager then returns the most recent memento, and the text editor restores its content using that saved snapshot. This allows the editor to return to a previous state without exposing its internal data. One advantage of the memento pattern is that it allows objects to return to its previous states without recreating them from scratch. It also preserves encapsulation because other classes do not need direct access to the object's internal state. Additionally, storing states in separate memento objects makes them easier to manage. However, there are some disadvantages. If many states are saved, memory usage can increase significantly. Managing a large number of mementos can also add complexity, and frequent saving may impact performance in some applications. These are the sources I used to research the memento pattern and verify my implementation. They provided explanations to the pattern's purpose, structure, and common use cases, and gave me a guideline as to how to implement it into my project. This will be the end of my presentation. I hope you enjoyed, and have a good day.